Hi, buddy. This is Mr. Folly, and welcome to podcast 10.3. We're going to learn what temperature can do to solubility. We're going to make saturated, full, unsaturated, unfull, and supersaturated, overfull solutions, and we're going to read a solubility curve. So let's get started. Temperature affects solubility. Warmer solutions usually hold more solid, so that means hot water will dissolve more sugar or salt than cold water. And hot water holds less gas always. Pressure affects solubility of gases. The greater the pressure, it'll hold more gas, but it'll have no effect on a solid. Less pressure holds less gas and no effect on a solid. So if you think about this, pressure is like the squeeze, the force of the squeeze getting in here. So if I have gas particles can jump up and let's get smacked back down by more pressure. Saturation levels. Solutions can be saturated, full of solute. That is a full bucket of chicken. Unsaturated, less than full. And supersaturated, holding more solute than it should, like that right there.
Hi.
So that is supersaturated. Saturated is on the line. So what mass will saturate 100 grams of water? Notice here it says we've got 100 grams of water at 20 degrees Celsius. Here's 20 degrees Celsius. What mass will do it? 25 or 30 grams, right? So I will say, is that smack dab in the middle? No, it's a little higher. So we'll say 30 grams will dissolve in it, because that number right there is 30. At 60 degrees, boop, boop, boop. I'll call that 115. And at 85, 80, there's 90. Half of that would go up to here. I'll call that 180. So all you do is just read the grams, look at the temperature, go over those things, make sure that the amount of water you're dissolving it in matches. Unsaturated is below the line. Is 150 grams of if 150 grams of sugar is added to 100 grams of water at 20 degrees Celsius, 150 grams, boop, 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 boop. Is it saturated or unsaturated? Well, it is unsaturated because it is below the line. If 250 grams of sugar is dumped in 100 grams of water at 40 degrees, 250 is dumped. Oh, is it saturated or unsaturated? Now notice, it's above the line. It's going to be saturated with, let's see, this right here is about 240 with 10 grams on the bottom. Okay, we'll call this about 240. That's where that came from. If a solution at 30 degrees Celsius has 30 grams of sugar, 30 degrees Celsius has 30 grams of sugar, how much is needed to saturate it? So if I've got 30 grams and I want to saturate it, so this right here is about 220. I need 220 minus 30 equals 190 grams added to saturated. Supersaturated solutions can be made. If you heat up water and saturate it, it has a bunch of solute. If you cool it slowly, you'd expect that extra precipitate out because, if at a certain temperature, if it's 60 degrees, it can hold this much. It can't hold more than this would be the expectation. But if, I suppose I'll do the graph. If I put this much in and I slowly cool it, that stays saturated, and then you get a supersaturated solution. So it usually does precipitate out, but some solutes don't do that. And now the cooler solution has too much solute, so it's supersaturated. The system is fragile, and often the extra precipitates out if you shake it or drop in an extra crystal. How do I make a supersaturated solution of NaClO3 at 40 degrees? So what I do is I saturate a solution, just say a 60 degrees solution. So heat it to 60, and then we'll say that's 168. And cool it to 40 degrees Celsius. If it precipitates out, what type of solution is it now? So if I put in 100 and whatever it was, 168, and I cooled it, and then it precipitated out. What type of solution is it now? Now it's saturated with the extra sitting on the bottom. PPT is a precipitate. Makes people think it froze. So when this happens, it precipitates and these solids form, and it looks like it froze. It didn't. Just the extra stuff precipitated out. Sample question for a solubility curve. Assume we have 100 grams of water for all these. What temperature has 80 grams of KNO3 dissolve? So what temperature has at most? We'll add at most 80 grams. So I'm looking for 80. Of what? KNO3. There it is. So what temperature is that? Let's see, this right here would be 50. So this would be 45. So this would be out 43 degrees Celsius. What temperature has 80 grams of KBr dissolved to saturate it? 80 grams, here's 80 KBr. Boop. Hey, that's the same one. What temperature? That's 43 degrees Celsius. What makes what mass saturates KBr at 70? 60, 70 KBr. Boop, 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 boop. It's a little bit above this, so it's a little bit above 90. I'll call it 92 grams. If I dump 120 grams of NaClO3 into 100 grams of 40 degrees Celsius water, 40 degrees, dump it in 120, 40 degrees, dump it in 120. Is it saturated, unsaturated? It's unsaturated because it's below the line. Saturated solution of KNO3 at 60 Celsius. KNO3, saturated. At 60 is cooled to 20. Boop, 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 boop. When one crystal is added, how much KNO3 precipitates? So remember, it's going to precipitate down until it's saturated again at this new temperature. So the saturation level at this new temperature would be about 34 grams saturates it. So if a saturated solution, and we started at 130, so 130 minus 34 equals 96 grams of precipitate. Bang. How to test for the type of solution? You just drop in a crystal. In a saturated solution, the crystal will sink. And in reality, it will dissolve and precipitate with different ones coming out. In an unsaturated solution, the crystal will dissolve. In a supersaturated solution, the crystal will make the extra precipitate out. Review. Saturated is on the line or over the line. Now remember, if it's over the line, what happens? It's just sitting on the bottom, not dissolving. Unsaturated is below the line. Supersaturated is where you saturate a solution and cool it carefully. Only extra precipitate comes out when extra crystal is added. To test for saturation level, add a crystal and see what happens. And remember, temperature affects solubility. Toodles.